this is the paper session number 4. We have 5 very interesting presentations. I mean, my name is Ruben Alonso from Natural Solution. We will start with INPERSO, with 2 presentations from INPERSO from the Universitat Politécnica de Valencia. Professor Luis Alapont will present the INPERSO project. Then Juan Gabriel Secondo Maglia will present the 3D printing system for facade restoration. And then we go to the Centro Tecnológico de la Construcción de la Región de Murcia. I think that Carlos will present, but Miriam is also here in case there is any question. So it's about the SNAC project and the advancing sustainable and energy efficient buildings through circular material innovation at optimal cost. So it's a little bit too long. Yeah. Then Julia de Aloisio from Certimac will present the circular building passport to support sustainable and positive energy homes, which is part of the LEGOFIT project. And then the session will be closed with Constantina Dia Andreoli from Mirtec, also INPERSO project, presenting mapping sustainability construction materials supply chains. And at the end, I will close the session. The presentation will be more or less 10 minutes, 12 minutes. We will do the questions after the presentation. If you have any question, anybody wants to ask something, please do it after the presentation. So we start with the presentation. We control the time and tend you to give you in the 10-12 minutes. Okay.
Thank you, Ruben. Thank you for your understanding of our needs and for make so easy everything to us. And I'm sorry for the inconvenience for the organization. Okay, presentation. Well, thank you for doing this presentation. I'm going to present the general aspects of INPERSO, industrialized and personalized sustainable societies. Well, I think here everybody knows this challenge, this big challenge to the construction sector. I think we have told it this morning in the first section. 40% of final energy consumption and 36 of greenhouse gas emissions. We are guilty for these numbers, and well, we have to focus on renovating existing structures to mitigate this problem. However, the renovation rates have stagnated. What is the proposal of INPERSO? INPERSO proposes innovative solutions, flexible to adapt to the specific characteristics and needs of each building and user, and industrialized and digitalized processes to improve the retrofit works, reducing the time and disturbance and increasing comfort and energy savings for everyone. Well, let's have a look, a quick look on the project in a nutshell. INPERSO tries to look into the problem from a threefold perspective: products, processes, and a human-centric approach. This means that we try to be holistic and cover the whole life cycle. That's because the project will feature 3 distinct phases: the decision and design phase, the first phase, pre-retrofit, that includes collecting all the data and the information, identifying system requirements, specifications, and developing low-carbon renovation models. Okay, we were talking about the second phase, during retrofit phase. We are going to install advanced renovation components and technologies. Well, we will see something more about it later. The third phase is the validation phase, validation and demonstration phase, the post-retrofit phase. Using wireless sensor network, the project will provide holistic energy management using AI and machine learning, allowing to users to optimize energy usage. Well, this is our consortium. It's a large consortium. We are 22 partners coming from 9 countries. Many people from Spain, but also from Greece. We are 8 RTOs, also 8 SMEs, many SMEs, and 3 large enterprises, and also 3 NPOs that are in charge of this of our 3 pilots. Well, let me. Okay. Now we move to the objectives of the project. We have 6 integrated results to achieve in INPERSO that are aligned with the project's objectives. The first is deliver integrated digital platform. The second one is to generate new carbon renovation models. Sorry. The third one is try to improve the using of advanced manufacturing technologies. And specifically, we are going to deploy on-site 3D facade printing that Juan is going to explain in the next presentation. We try to also address personalized energy and comfort requirements of users. And finally, we want to deliver a complete system test in the 3 pilots that we are developing. And we are going to do this using advanced technologies. Starting with the RE Suite platform, and that is an AI and AR-based solution. The platform has been already developed in the project. We are in the 3rd year of the project, and it's been tested in the 3 demo cases in different scenarios. All the information and data are available through a user-friendly interface, and we are including the Sky tool that can recognize objects from a points cloud and integrate it into a BIM model. It is also connected to the Rialto application, which uses artificial intelligence technology to audit and report on construction management work. And R2M is developing a big part of this. Moving to the low carbon renovation models, INPERSO aims to address the fragmented construction value chain. Low carbon renovation models developed are prioritizing user satisfaction and sustainability, working together with all the stakeholders. We have developed also a dynamic map that has been integrated to the RE Suite platform, which will help all participants to make better decisions. The energy and comfort optimization interface is the last one of the digital tools. We have, well, it consists of a multi-stage energy consultant system that is connected to this interface. Using a low-cost wireless sensor, wireless network sensor to evaluate air quality, energy demand, and comfort conditions. And finally, the retrofit kit, the physical part of our project. It aims to reduce construction and demolition waste, enhance productivity, upskill the workforce, improve workplace conditions, and reduce embodied CO2 of buildings. This is the retrofit kit. We can start with the smart wall. It's a prefabricated all-in-one wall panel. It's a multi-layer system that can even include autonomous air conditioning devices and other types of products as PV panels and so on. The second is the energy pod. It's an intelligent plug-and-play HVAC system that uses PCM material, and it incorporates also energy storage and PV inverter. The third one is this type of building integration photovoltaic panels to be installed in roofs and balconies with a special interest in heritage buildings. Next, we have solar window. The solar window includes a PV Venetian blind shading device inside an insulating window between two glasses. And well, this kit is composed by some of our innovative products that INPERSO is going to integrate in the pilots in order to achieve TRL 8. Of course, we have the 3D printer system, but I'm not going to talk to you about it because the next presentation it will do. Okay, let's move to the pilots, to our 3 pilots. We are going to explain briefly these technologies that have been implemented in the demo cases. One is located in Spain, the second in the Netherlands, and the third in Greece. The first is a social housing rental building whose main facade and volume are protected and with market on its ground floor. Well, Calle Estrella is located in the historic center of the city, and you can see in the pictures the 2 facades that has the building, one facing to the city and the other to the courtyard. And well, we have had multiple difficulties to develop this project, but finally we are developing the project. Of course, we are monitoring 10 of the 16 apartments, and we are doing interventions in 7 of it. The first one is installing 6 new balconies with 5 PV panels, groups of PV panels that are going to be installed in the back facade that is not protected, and will receive this facade a commercial ethics. You can see the final design on the bottom right side of the screen. We are going to install we are going to install in 4 apartments this type of solar windows that are designed specifically for the protected facade, the main facade. We are also installing 4 units of the smart wall on the indoor side of the facade. And finally, 4 units of the energy pod will be fitted in 4 apartments. Moving to the next pilot, the Trinity Complex, it's in Bell. There are 3 high heritage protected buildings, the church that was not allowed to intervene, and 2 ancient monasteries, one called Emmaus and the other Bronhorst, that have been converted into temporary residences for low resource people. Due to this high level of protection, the intervention has been finally restricted only to Bronhorst Monastery, which has been monitored since the beginning of the project. Well, despite of the small scale of the intervention, a big impact is expected due to the big issues that always appear on this type of heritage building. Well, the work is small, but the results are huge. Only 1 room is going to be intervened, installing a solar window and a smart wall unit. But also we are going to install on the area 1 energy pod on the attic to supply 2 of the rooms. And finally, we are going to do the most interesting intervention for me, the most interesting restoration work that it consists in replacing part of the damaged chapel roof with photovoltaic tiles. with the same shape and the same finish as the originals. Well, this is the third pilot. It's located in Baribola, Poliameni, near Athens. I don't know if I have said correctly. It has yet completed already completed its renovation, and unlike the previous two, we are starting it in the coming months. And it consists of the energy renovation of a social residential building that is built in the 1960s, now dedicated to people at risk of exclusion. In this case, in order to compare INPERSO technologies with traditional solutions, a commercial ethics has been applied to some parts of the facade. On the right side, you can see in two levels, in blue, and on the left side, you can see in the side facade and the main facade, the southeast facade. At the same time, the smart wall solution was installed in the first level of the south facade, as you can see in pink, employing 27 units, 4 of them with ventilation system integrated. INPERSO panels from Metso were also installed at the pergola, as you can see in green, and the roof. Conventional panels, not integrated panels. And finally, this is the last, sorry, Ruben, for the extension. We present the expected impacts that are already being evaluated. You can see both time and cost savings and quality improvements regarding the full life cycle, the construction phase, and the operational phase. And thank you for your attention. That's all.
If anybody has a question while I do the next presentation, feel free to ask.
Yes.
You
now, because we are going to
yeah.
leave.
No, I have a. I mean, do you have anybody have a question about the project? If not, I ask. Okay.
Come on.
I mean, I saw that you had a few sessions with the stakeholders.
Yes.
How different were between different countries? I mean, you did I support one in Spain, one in Netherlands, one in Greece.
Yeah. Well, I'm not directly participating on the sessions, but I know something about it, of course. I think in Greece it was very, very difficult because tenants or residents are people at risk of exclusion, and they are not very interested in this type of renovation and so on. And they are changing, I don't know, every period. I think that here the most important is the managers of the building, the contact with the managers of the building. They are willing to participate and to do this type of renovation. That was good with them, but with many restrictions about the residents. In Spain, it has been difficult, but I think it has worked better because the tenants, because they are tenants and they are not owners, it's managed by a public company, AUMSA, and they are in contact with the tenants every time and trying to engage them, and well, with the help of our partner that is represented by Raúl. He's from Tau, and they are doing a very, very good job with people. And well, I think that's because in Valencia we have been able to intervene with many in many apartments and with the engagement of the people. And in Belp, well, it's more or less the same with the residents as in Greece, but it's more difficult because the managers of the building have been changed and they are not very involved in the project. That's because the size of the scope of the place.
Okay, thank you.
Thank you.
Luis.
Thank you, Ruben.
Juan Gabriel, please, if you can present your.
Well, I also want to thank you, Ruben, for allowing us to be first. We have a problem with the flight, so that's why. So, well, I'm Juan Secondo, and I'm representing the technical management team in the Universidad Politécnica de Valencia, led by José Luis. And I'm going to present a 3D printing system for facade restoration that is co-developed with VIAS, ITA, that we also have Carlos here, Cartif, and us, Universidad Politécnica de Valencia. So I titled it Overcoming Low Productivity and Integrating BIM Technologies. So I will briefly go through the context and previous experiences regarding 3D printing. The INPERSO project I will be very brief because Jose Luis has introduced very good the project. And then the perform test until now, the positioning system and extrusion tests, and the conclusions with the main remarks and future work plans. So the current situation is that we have a construction sector that is facing huge challenges regarding the adoption of new processes and technologies. Industry 4.0 is crucial to help accelerate processes and gain more quality increase and safety. And we can see that prefabrication has already gained a lot of momentum, but we are still lacking the provision of flexibility and adaptability in the on-site work. So that's why we are, let's say, the context of this technology. So we need to aim that construction can merge industrial precision and speed with the adaptability of the traditional methods as well. So as UPV, we had some previous experiences in horizontal printing, always generating the codes for the trajectories and exploring with the different kinds of pumps. And we have also as the context that VIAS and Cartif worked in a project called 3D Cons that had some of the preliminary experiences in printing vertically. So, as you know, Jose Luis already explained the project very well. We have 3 demonstration sites, but we are focusing now on one of the technologies that is aiming also to level up the TRL, that is the 3D printing. So in the scope of INPERSO, we have that we are developing the extraction, this is our task, the extraction of the BIM software of the layer that we want to print. And with this, we have a main orchestrator that uses the 1 to 2 G codes that we are programming, one for the global positioner that positions the pump in different sections. And then we have the robotic printer arm and mortar pump that are going to print in an area of 1.5 diameter circle. So when we focus on the global positioner, is being developed by ITA, and we have an XYZ axis that are being, let's say, developed with a motorized trolley with a rack and pinion mechanism for precise facade positioning. And this system has achieved a very precise and stable structure that was also developed considering the stability of the system. Then regarding Cartif and ITA and VIA, sorry, we have, I don't know if it's transition. Yes. We have a UR20 robot that is the one in charge of the positioning of the pump and the printing. And this has been developed ensuring a flowmatic extruder with dual cameras that also help monitoring the 3D printed areas. Also with a LiDAR system that detects the elements that may be collisioning with the system or that may not be present at the BIM model or at any of the scanning elements. Also, it's important to say that R2M has provided the scanning of the building, so we have the pre-existing conditions of the work. In our task as a UPV, we are, as I was saying, developing the transfer from the BIM work till the GR codes. So as you can see here, we have the wall partition in the BIM with the openings, and then we define the areas that are the maximum areas that can be printed by the robot. So we position these areas considering the holes, and then we define the trajectory from point A to B, knowing that we want to aim the shortest time and the best adherence and the best conditions for the surface quality. So we aim at the less assistance from an operator as possible. Finally, when we talk about the printing process, there were many tests. So we had to test the adherence, as I was saying, how this much distance of the layers, the flags of the product so we can aim to the most optimal surface, so then the operator has to do as less possible work, the less possible work. So the aim is to perform with little human assistance, as I was saying. It's important to say that this robot is a collaborative robot, so we are aiming to also for the safety of the operators. Here we can see how at the beginning we were testing in a 6x6 surface, how these 1.5 per 1.5 squares were going to 1.5 circumscribed square within the circle was going to be positioned, and then testing the different kinds of distance between the layers and the extrusion of the pump as well. Here we can see the LiDAR element that is also detecting any variation in the surface for this to be done in the perfect way. So as main conclusions, we can see that this technology aims for existing buildings, which is one of the biggest challenges in construction, and also we are trying to aim for energy renovation, so to give this mortar the thermal properties in the future, so we can actually use it as an insulated element. As you know, outdoor insulation is the best solution for avoiding thermal breaches, so this is a good road of work that we are in. So also the collision identification, not just for the openings, but also for the overhangs and elements that may be present, is a very huge problem of the retrofitting industry. And also the BIM workflow will allow for much better and fluent relation between the project and what is actually performed. Also, when we include these scanning elements with LiDAR, we can have very precise approach of existing conditions, which is not always as projected, as you know. So, thank you very much. If you have any questions, please.
Very interesting and quite impressive. I like it. How does the thing stick to the wall? Is it sticking or is it falling sometimes? Or?
Yes, for that, that is being developed by BIAS, the material composition, it was very important to ensure the right amount of viscosity to stick, but at the same time, the right amount of fluidity to circulate smoothly in the pump. So this was performed with a lot of tests in order to achieve the best.
And I was wondering, when you top, in many cases when you renovate, they use this mesh, this very fine mesh, right? And manually they put the mesh and slap the screed on top. You're looking to do that as well, to see how, when you introduce this extra layer component, is that necessary, or I don't know?
Yes, I understand that in the future, because we are still on a very controlled area, but it should require some mesh, because when you are working with very long surfaces, that's why it's so important that it's a collaborative machine. That is not, that you leave it working and you go away, but you really need the operator to be doing this kind of continuity of the material.
All right, well done.
Thank you.
Okay, thank you. I think that we can close the session. I want to thank José Luis, Juan Gabriel, Carlos, Julia, and Dia for the presentations. Also all the projects like INPERSO, SNUG, and LegoFit, and all of you for coming. And see you next year, probably in Luxembourg for Sustainable Places 2026. Thank you.